Thomas, bringing you another video. In this video, we're going to be going over the solutions to quiz number 4. So we're just going to get started. Quiz number 4 was based on exponential functions and logarithms. And so let's just go through the solutions here. Number 1, it says, given the function f of x equals 2 to the x minus 2 plus 2 in the xy plane, sketch the graph of the function. So all it says is sketch the function. And so we're really testing to see if we understand what an exponential function really looks like. Okay, that's actually seeing a little bit too much there. Let's swing that up. Switch back our pen. Okay, so there's my x-axis and my y-axis. Now, usually when you make a sketch of a function, you want to put in any of the asymptotes, if there are any. Excuse me. As you know, exponential functions have a horizontal asymptote. And so because this function is plus 2, it means it has been shifted up twice. The vertical asymptote is not at the line y equals 0 anymore. It's more at the line y equals 2. So at 2, we have what's called a vertical asymptote. Another important point is to figure out what the y-intercept is. So let x be 0 and then solve for the y. Usually, to make a nice sketch of an exponential function, you really just need about 2 or 3 points. And so if we let x be 0, and I plug that in there, I'm getting 2 to the negative 2 plus 2, which is nothing more than 1 over 4 plus 2. So that's 2 1/4 for 2.25, 2 1/4. And so we know when x is 0, it's just off that axis. And we also know when x is 2, we're actually at the point 3. So if there's my 1, there's my 2, there's my 3, and I have another point here, I can now sketch my function. It's going to look something like that. And it just shoots up. And keep in mind, this graph has been shifted to the right 2 units and shifted up 2 units from its normal curve. Now the question is, find the domain and range. Well, the domain for exponential functions are all real numbers. And so there are no restrictions to the x values. I can plug any x real number inside my function and I will get a real number output. And so because there are no restrictions, the domain is all real numbers. The range, on the other hand, is limited. It's bounded by the horizontal asymptote. And so it's all values bigger than 2 out to positive infinity. And so my range, and it doesn't include 2 because obviously if you have a horizontal asymptote, there is no value of x that will give you 2. And so this would be sufficient. Let's move on. Number 2, it says an infectious disease spreads to in a small city of population 10,000. After T days, the number of people who have succumbed to the virus is modeled by the function. So we have our function, and now the question is, how many infected people are there initially? So, and that is when t equals 0. This problem we can pretty much do this in our head. So v of 0 is nothing more than 10,000 over 5 plus e to the 1 power, e to the 0 power. That's 0 times negative 0.97 is still 1. It's going to be 0, which gives us e to the 0 power, which is just 1. So we have 10,000 over 5 plus 1245. That's 10,000 over 1250. Now, 1250 is actually a pretty nice number. If you double 1250, we get 2,500. And 2,500 goes in there 4 times, and so 1250 will go in there exactly 8 times. And so we can now answer the question, the part A. It says, how many infected people are there initially? There were only 8. And now the question is about how many people were infected in 5 days. And so we're going to let t be 5 this time. And you're going to plug this in. Now, this is basically a calculator problem at this point, a scientific calculator problem. We get 5. And then e to the negative 0.97 times 5 is what you needed to do. And when you evaluate all of this, we get a number approximately, you can round it off, about how many people were affected. A good estimation would be 678. Okay, it says express the equation in logarithmic form. And so we needed to rewrite this problem with the base and the power and all of that. And so we have log of 2, log of base 2, the 1/8 is equal to negative 3. And so there it is. We have it in exponential form, and this is the logarithm form. The next problem is same idea, log base e, but we can also call that ln. And ln of 2 is equal to x. And so there it is. Those are the two logarithmic forms. Keep in mind, if I did log of base e to the 2 is equal to x, I would give you credit for that as well. But you could just go one step further. It turns out that the log of base e is actually the natural logarithm, because we use base e so much that it has its own symbol in there. It says evaluate the expression. So the key to evaluating these expressions is to rewrite them in terms of its exponential form. So we have log of base 5 of, say, x is equal to base 5 to the 4th. Now, because they have the same base, we can set the powers equal to each other. And so the expression, I let the expression be equal to x. The expression is actually equal to 4. And same idea here. 3 to the x power is equal to 1 over 27. We can rewrite this. So that implies, I'll put an arrow. 27 is really 3 cubed. And one more step, we can write this as 3 to the x is equal to 3 to the negative 3. And therefore, x is equal to negative 3. And so we found both of the answers there. X is 4, and for B, we get x is -3. It says expand the given logarithm. And so we have a product, and each product can be written as an exponent. So it's nothing more than log base b of x squared plus log base b of y to the 1/2 power. And I can rewrite both of these as 2 log the base e of x plus 1/2 log b y. Same idea here. Expand. I can rewrite my log as the log of x over y to the 1/3 power. And therefore I get 1/3 is equal to the log of x over y. And that's nothing more than just 1/3 of the log of x minus the log of y. Now that's one way to do it. We could also distribute the 1/3 in there. We could have did that from the beginning, the cube root of x over the cube root of y, and then expand it out that way. Either way is good. Either way is fine. Let's move on. This is right as a single log this time. And we have a sum of 2 logs, so they have the base 10. So we should be able to do this no problem. And also, we can rewrite these as powers as well. So I can write this as log of x to the 1/2 plus the log of x minus 1 to the 4th. And that's just the log of x to the 1/2 times x minus 1 to the 4th. Okay. Same idea here. We got ln x to the 5th minus ln y to the 2nd, and that's equivalent to the 5th over y squared. Final answer. Let's keep going. Solve the equation 8e to the 2x equals 20. So isolate your exponential term. Divide both sides by 8. We divide both sides by 8. I'm getting e to the 2x is equal to, well, this reduces down. 4 goes into both of these numbers. So I'm getting, let's just put it up here. I get e to the 2x is really equal to 2.5. And now to get rid of the base e, I got to take the natural log of both sides. You take the natural log of both sides, so I get 2x is equal to the natural log of 2.5. And therefore, x is equal to 1/2 of the natural log of 2.5. That is approximately, that rounds off to about x is 0.458 approximately. So you could return either answer. This is actually good enough, the exact answer, or you can give an approximation. Solve the equation. The first thing you got to do is rewrite it in exponential form. So I have 2 to the 3rd power is equal to 25 minus x. So that's really 8 is equal to 25 minus x. So x is really 25 minus 8. And therefore, 25 minus 8 is just, what is that, 17? 25 minus 8 is 17. And if you plug 17 in there, You should get it. Let's look at 9. Here we go. We can write this as a single log. I can write this as log 2x times x minus 3 is still equal to 2. And I'm going to rewrite it in exponential form. This is 2 to the 2 power is equal to x times x minus 3. Now, because this is a quadratic equation, I get x squared in there. I need to simplify this and set my quadratic equal to 0. And so all I got to do now is move my 4 over and then switch it around. So I get x squared minus 3x minus 4 is equal to 0. X minus 4 and x plus 1 equals 0. And then my two answers are x equals 4 and x equals negative 1. The problem is that logarithms aren't defined for negative values. They're not part of the domain of that function, of a log function. Log functions are bounded by the vertical asymptote x equals 0. And so you can't plug in 0 nor any negative value. And so this is considered an extraneous solution. It's not a solution at all. The only solution we get is x equals 4. And the last problem, number 10, it says the Call of Duty franchise has sold more than 100 million games since its first video game in 2003. The annual retail sales have had exponential growth, started in the year 2004 when the retail sales were $56 million. In 2010, Call of Duty Black Ops was released and eventually made 980 million in retail sales. So based on the data above, find the exponential growth model. And so we need to know that initial amount. So basically A sub naught is going to be the 56 million. And our units can be in millions. And so I'm going to use that 56 e to the kt. The next thing we have to find is k. And we need to use the fact that in 2010, the data point that we have here, that in 2010, the retail sales was 980 million. And so we need to plug this in. Now in 2010, when t sub 0 is in 04, how many years have passed from 04 to 2010? Well, we'll have to let t equal 6. 2010 from 04, the difference is 6 years. So we let t equal 6. And then we also let our annual sales be 980 million. So we have 980 is equal to 56 e to the kt power, but t is actually 6. And we need to actually just solve this equation now for k. Well, if we can solve this equation for k, we will have our growth model and divide both sides by 56. So we get e, I'll switch the equation to the other side. I get e to the 6k is equal to 980 over 56. Notice I did not figure out what this decimal approximation is just yet. If you do that, sometimes you can get a round off error. You're going to be careful about that. Now, let's take the natural log of both sides. That will get rid of our base, and we'll be left with the natural log of 980 over 56. And now just divide both sides by a 6. And so k is equal to 1/6 times the natural log of 980 over 56. So k is actually approximately 0.477. That is a lot of growth. My exponential model for part A would then be A is equal to 56e to the 0.477t power. And so there we have it. A is equal to 56e to the 0.477t. The last question, though, it says, now based on our exponential growth model, about how much should the retail sales be in 2016? So and so we need to let, in this particular problem, we're going to have to let, see here, hold on. All right, so for this particular problem, we're going to have to let t be the difference between 2016 and 2004 or 2004. How many years have passed between them two? That's actually 12. So we're going to let t equal 12 and plug that into our model. Times 12. And so when we do that, we're going to get this huge number. We actually get 17,150 approximately. That represents million, but the truth is the actual amount would be 17 0.15 billion in sales. And so there you have it. Those are the solutions to quiz 4. I hope this was helpful. And if you have any questions, as always, reach out to me. I'll be more than happy to help you. Take care. Bye-bye.